Okay, today we're talking about converting between moles and mass and moles. And the first thing that we need to understand before we can convert between mass and moles is the concept of molar mass. Molar mass is the mass in grams of 1 mole of a substance. So if I have 1 mole of water, that's 6.02 times 10 to the 23rd molecules of water, their mass would be 18 grams. So 1 mole of water has a mass of 18 grams. And we can calculate that using the periodic table. We're going to go ahead and look at this example right here of magnesium hydroxide and calculate its molar mass. Once we know what its molar mass is, then we can use that molar mass to create a conversion factor that says 1 mole of magnesium hydroxide is equal to this many grams of magnesium hydroxide, and that's all I need to convert from moles to mass. So I'm going to use a periodic table. So first thing I'm going to do is look up the mass of magnesium. Magnesium is right here. Its mass is 24.30. For the purposes of this class and simplicity, we're just going to go ahead and round those atomic masses to the nearest whole number. So 24 plus oxygen, which has a mass of 16. And I need to remember what my subscripts are for. So a subscript outside of my parentheses applies to whatever's inside that parentheses. So that means I have 2 oxygen atoms. So 24 plus 2 times 16 plus the mass of hydrogen, which is 1. And again, there are 2 hydrogen atoms as well. So if I take 24 plus 16 times 2 plus 1 times 2, that is equal to 58. So the molar mass of magnesium hydroxide would be 58 grams. And again, I need to understand what that means. That means that 1 mole of magnesium hydroxide is equal to 58 grams of magnesium hydroxide. And then I can use that conversion factor to use dimensional analysis to solve these problems. So let's go ahead and scroll down and look at, let's say, problem number 4. All right, find the number of moles in 937 grams of calcium acetate. All right, so I'm going to start like any other dimensional analysis problem, any other mole problem. I will begin by drawing my dimensional analysis setup. This question is asking me to find the number of moles. So I want moles, and we're talking about calcium acetate. So moles of CaC2H3O22. So that's what I'm looking for, moles of calcium acetate. And my starting point is 937 grams of calcium acetate. Should have left myself a little bit more room here. 2. All right, so at this point I want to ask myself, what conversion factors do I need? And you should have your reference. We have our 3 conversion factors, number 1, number 2, number 3. There's also 1b. I'm not going to write those down, but we know that our keyword here, grams, anytime I see grams, anytime I see mass, if it's asking me for grams or mass, this asks me for grams, this gives me grams. If it gives me mass, gives me grams, asks me for mass, or asks me for grams, I know I'm going to need that second conversion factor. That second conversion factor is the one we just created, molar mass. So I'm going to write that off to the side here. 1 mole of CaC2H3O22 is equal to however many grams of CaC2H3O2. So I need to first calculate that. So calcium, I'm going to look at my periodic table and see that it has a mass of 40 plus carbon, which has a mass of 12. All right, and then I have to calculate how many carbon atoms I have. So I have 2 here, but then there are 2 acetates. So 2 times 2, I'm just going to distribute this 2. So 2 times 2 is 4. 4 carbon atoms plus hydrogen, which has a mass of 1. And there are 2 times 3 hydrogen atoms, so 6 hydrogen atoms, plus oxygen, which has a mass of 16. And there are, again, 2 times 2, which is 4. All right, so when I add all of those up, that is going to give me the molar mass of calcium acetate. And that is 158 grams. So again, if I had 1 mole of calcium acetate, it would weigh, or have a mass, of 158 grams. So now I can plug that in. So here's my conversion factor. I'm going to go ahead and erase, well, I'll leave that there. Here's my conversion factor. I'm going to plug that in the way that it is because I want grams down here. So 158 grams of CaC2H3O2 is equal to 1 mole of CaC2H3O2. And that's the unit that I want to end in. I want moles of CaC2H3O2. So grams of calcium acetate will cancel out, and I'll be left in moles of calcium acetate. And now all I have to do is enter that into my calculator. 937 divided by 158, and that equals 5.93 moles of calcium acetate.